To power series. So this should be a bit of a review from calculus, but we'll go through and just sort of look at the various definitions. So power series in x minus x naught takes the form the sum from n equals 0 to infinity of a sub n times x minus x naught raised to the n, where the a sub n's are constants. Power series is said to converge at a specific value of x if we take the limit as capital N approaches infinity of the sum from lowercase n equals 0 to capital N of a sub n times x minus x naught raised to the n, if this limit exists. And so in this case, that a sub n again, or these are essentially looking at the partial sums, and if we keep adding terms to our partial series, it goes on to an existing limit. And by exists, we also mean that it is and is finite, right? So we're not taking infinite limits. Depending who you talk to, sometimes people will say that limits at infinity, they still count as existing. All right, so a little theorem here. Given a power series in x minus x naught, one of the following three holds. So one of the following three statements is true. Option 1, the series converges only at x equals x naught. Option 2, the series converges for all real numbers. So the series converges for all x in the real numbers. And option 3, there exists capital R in the real numbers such that the series converges for all x with absolute value of x minus x naught is less than R, and the series diverges for all x with absolute value of x minus x naught greater than r. So we call this capital R the radius of convergence. So our power series, or so the radius of convergence of the power series if we're in case 1, then we say that the radius of convergence, or R, is equal to 0. And if we're in case 2, then we say the radius of convergence is infinite. So if we have a finite radius of convergence, then it precisely matches the R from the theorem. And otherwise, if it's just at x naught the series converges, we say R equals 0, the radius of convergence is 0. And if it converges for all real numbers, then we say the radius of convergence is infinity.